Okay. Then I talk about running Windows on ARM on KVM. So first I talk about my motivation. So well, I had to pay income tax and open the Japanese National Agency's website, and they said no Linux, use macOS or Windows. But all my data is on Linux. And so spoofing user agent feels kind of cheating. So I just decided to run Windows. And my MacBook is has Apple Silicon, so I decided to run Windows on Federal Asahi Linux. And the good news is that Windows on ARM actually runs on QEMU. So Microsoft recently made RT build available for download, and provided detailed instructions to how to run this build on QEMU. So yeah, the most difficult, complicated task is already done. So I have to do that. And there are some challenge specific to Asahi, so Apple Silicon. And so the problem is Windows required a PMU. So the ARM architecture specification actually made the PMU optional feature, but Windows decided not to check the feature set and just fork registers, so it crashed without PMU. And even the user space API exposes the cycle contrast, so PMU is kind of hard requirement for Windows. And I had no idea how to enable PMU on Apple Silicon, but another good news is that now upstream Linux has a PMU support on Apple Silicon. So that problem was already solved. And so in this, and this feature was not implemented in macOS. So in this sense, Asahi Linux outperforms macOS again. There's one caveat. So this PMU emulation of KVM does not support heterogeneous configuration. So it is necessary to limit cores to particular cluster, P cores cluster or E core cluster. But with this core limitation, you could run VMs with PMU. But just running Windows is not sufficient to pay tasks. Well, I also need graphics for running browsers and clipboard sharing to transfer my income number to browser. And I also need to run this on Asahi Linux because the Apple Silicon laptop, this MacBook is the best one, the best computer I have. And so I just tried the conventional way for x86 Windows, and that is to use bat installed for machine configuration and bat.iowin for power choice devices, and Spice agent for clipboard sharing. And then I configured machine and started, and it doesn't work, and it doesn't even show any display output. And it turned out I had to charge every layer of virtualization. First, I had to update the management layer for machine configuration, proper machine configuration. For better PMU support, I had to hack KVM and QEMU. And power virtualization stack, driver and guest agents needed updates. So it's pretty much everything. The first challenge is to update the management layer for Windows on ARM. Simply, but install did not know about Windows on ARM, so I just added definition. The script to update definition was also kind of hard bug, so I fixed it too. And then Windows on ARM definition is now added to OS info database. but it still doesn't work. Now it knows it's Windows, but virgin store tries to configure machine based on x86 knowledge. So it just thinks x86 Windows. So it has lots of things not aligned with ARM. The biggest issue is driver. Windows on ARM has very limited set of drivers. Windows on ARM only supports Hyper-V, Azure, Desktop, virtualization, and several X3s. So I had to choose devices compatible with these platforms, or Windows just don't have drivers and fail to use devices. The first challenge to choose appropriate storage device. The logic to determine storage device is kind of complicated in bad install. So first, it assumes that everything on bad machine is bad IO, and that is not true. So I removed that assumption, and then it's rejected all bad IO devices this time. Even for Linux. So because of the virtual logic had a hard assumption that only x86 supports bad IO. But that's obviously not true. So I removed that assumption too. And then it started using SD card for some embedded system. So no, it's not the embedded system we are using. So I changed it too. Then it starts using this type IDE. No IDE on x86. So in the end, I added USB as an architecture agnostic portable fallback, and then storage is now working. And for some device, I also instructed to use USB. Somehow Linux distributions use Intel chipsets even on output, which is very awkward, but yes, just worked because its driver is enabled. But that's not true for Windows, so I had to use USB. And the next one, display. ARM has very special in this area. Other architectures, including long range and disk-5, support VGA, but somehow QEMU and EDK2 decided not to enable VGA for ARM, so I had to choose RAM-FP. It has a limitation with display resolution, but it actually does work, and so this enabled display output. And fixing batch install tests on Asahi Linux, I also tested these changes, and now batch install is ready for Asahi. And then EDK2 boots, but installer doesn't boot. It turned out this time the problem was in QEMU. So QEMU had some kind of fixed memory map, but in this memory map, it requires a somewhat big physical address space, 256 gigabytes, but Apple M2 only supported 64 gigabytes memory map, so it didn't work. So I changed the memory map to remove the assumption that there are plenty of physical address space from QEMU. And then now installer boots, EDK2 correctly recognize that installation media. But now EDK2 recognize installation media, but Windows doesn't. And so for this problem, the code was in libvirt. Libvirt was failing to configure USB as CD-ROM. Most people don't use USB for CD-ROM, just use SCSI IDE for all platforms and so on. But Windows requires USB for CD-ROM, so I had to use this, and I had to fix labor to configure USB profile for CD-ROM, and then Windows can recognize it as CD-ROM and decide and allow it using UDF file system. And the installation media is now recognized by Windows, and finally installation pin was passing. And then now I have properly running Windows installation, but the display is very small. Its resolution is 800 by 600, so it's not really possible to pay tax with this small Windows. So I have to use Butter GPU. Butter GPU allows Butter GPU tells the host window size and allows the guest to configure the display resolution properly. And I installed Butter GPU, but it didn't work. It did output, it did have display output, that's delivering, but its display was still small. The problem was, and I did the driver code, but it turned out the problem is on the host side. The host side is a complicated setup, so it had SPICE protocol, and SPICE protocol had both host internal concerns and guest agents connection, and that tangled protocol caused it not update the display resolution when SPICE guest agent is not present, and the guest agent was not installed on Windows side. So I changed the server code to update the display resolution even the guest agent is not present. And now I have bigger display, and it crashes. Well, yeah, it turned out Butter GPU driver had a problem. So the VM execution was slow in the debugging setup, but that overflowed virtue link. Virtue link had a fixed limit on this driver, and that limit overflowed when the virtue's descriptor was consumed slowly. So I added dynamic memory allocation for the overflowing scenario. There's one big problem still remaining. So it doesn't handle dynamic memory allocation failure, just like Linux driver does. So it has a risk of burst screen death when memory resources scarce, but in most cases, this works. And well, during Windows driver development, I faced some issues, so I fixed them too. The first one is with the PMU. So as I said earlier, I had to limit the cores. I had to limit the VM to particular process core, but process cluster. But it's limiting. Well, I'm building drivers, and it's nice if I could have more cores, and it's also troublesome to run task set command to manually configure this. And so I added a heterogeneous process support. So in this heterogeneous process support, all host PMUs are combined to create one emulated PMU. And this emulated PMU only exposes the cycle counter, which is the only requirement, architecture specifications requirement. So with this change, I could expose PMU feature with on any heterogeneous core and without causing problems with thread migration. And next program is GDB failure. So GDB, when breakpoint is triggered, QEMU poses VM, and that resulted in string failure. It turns out it the make the logic to restore system registers was flawed. So QEMU restores all registers when resuming from GDB, but the logic in KVM was not designed well in this scenario. So QEMU did restore the PMU registers, but it didn't synchronize its state with the underlying PMU path event backend. So that caused state desynchronization and caused cycle counter leaks that in turn crashed Windows. So I ensured that state is properly synchronized in KVM side. So this time I had to fix KVM. And the PMU register had another problem that is with write to clear registers. Write to clear registers are so much strange registers. If you write value with bit, if you write a value with bit set, it instead clears. So that's a bit confusing semantics. And well, indeed, KVM and KMU was confused with the semantics. So KMU somehow decided to hide these registers from GDB, so I couldn't really inspect what's happening with these registers. I changed to expose them to GDB. And then KVM had a problem that restoring the register contents actually cleared the values. So it means it incorrectly implemented the right to clear register, right to clear semantics when restoring system registers for GDB region. So I fixed it too, and now all state restoration from GDB is fixed, and so GDB is now working with Windows on ARM, and now I have a functional debugging and testing environment for Windows drivers. The last challenge is to share clipboard. Well, it's very simple, just sharing clipboard, but it didn't work too. So SpiceBuddy agent is a component that provides guest assistance, and that is included in virtual WinDriver ISO, but this binary didn't work. It turned out the latest commit work, so I added Upware and GitLab CI build system. So now SpiceBuddy agent's latest builds are now provided on Upware and GitLab. So you can download the latest, you can grab the latest build from GitLab CI to run SpiceBuddy agent if you want to run. Actually, reproduce this Windows on ARM from KVM. And then now I could pay task without facing penalty. So yeah, I managed to pay tax, but it doesn't mean that Windows on ARM is ready for end users. There are many programs remaining. The biggest problem I see is VirtualBox stalls when shutting down machine. So you cannot shut it down. You cannot shut down. It just freezes. So and the strange thing is that it works fine, but with TCG. So something with KVM or Asahi is wrong. But I haven't. They get plug in this issue much. The current workaround to just reboot and tell reboot to destroy the VM when reboot is triggered. And as I noted earlier, battery GPU do not have the dynamic memory allocation failure, so it needs to be fixed. And battery GPU cannot even just put blue screen of death in this scenario because it expects VGA interface. So battery GPU driver needs to be fixed, or maybe enabling VGA in QEMU may be an option. And that install still uses Intel Architect 9 for audio by default. So ideally, it should use USB for Windows on ARM, but it also needs or libOS for library to differentiate Windows on ARM and Windows on x86. But it is not supported because the XML schema does not express the architecture constraint. And there are many more of open issues. The Spice development is becoming less active, so we need some alternative. DBus may be a good alternative for host side, but not guest side, we still need Spice. x86, the binary is still on Windows, and packaging is another challenge. And upstreaming is also still in progress. So if you are interested, please review the changes. And takeaways, system register characteristics are somewhat confusing, so it may need some work. And hard-coded assumptions are evil. Better compatibility also leads to robustness, so please care compatibility. And Windows support in general requires more work. And it will be nice if Apple and Microsoft improves their virtualization stack for macOS. We fixed KVM, but macOS still supports some problems. And national tax agencies should tolerate Linux. The other agencies should also. Thank you for listening. Do you have time for questions? So any questions? Hmm? Hmm?
How does that work on actual Windows hardware?
Well, this is a problem. This is a program in battery GPU. So bare metal systems use different drivers. So it's not problem for bare metal systems. Any other question? Well, the fix is already merged, but not sure if new release was made. And also, battery GPU installation is a bit convoluted. Not just installing driver is sufficient, but you need to install a service for dynamic resolution change. No, so yes, that's also some work can be done. So if heterogeneous support in QEMU is improved, then we can certainly benefit from this for running Windows on ARM for heterogeneous system too. I didn't hear. Yeah. Yeah, works, but yeah, yeah.
Next point, instead of USB, it would be probably better for storage to use NVMe. NVMe was box, Windows whatever it is, pretty good. So I've been Windows code and using maybe as the backing storage and as script in QEMU as well.
Yeah. That's great to hear. Well, I also thought of that option, but install didn't. But manager didn't support that option, so I just chose USB. Yeah. It's um. Thank you for information.
Graphics slides.
Hmm?
Key recommend is to use
Yeah, indeed. Yeah. Well, many devices do not work. Many PCI drivers are not present. And even for USB, well, USB network driver was not present, so I couldn't enable network without installing virtio-net driver, NetKV driver. Well, it just crashes. Well, it should be there. Well, processors will be killed fast, and we don't need much memory for but a GPU driver. But it's a theoretical possibility and better to fix if possible. Mm. Yeah, indeed. Time out. Thank you for question and thank you for listening.